Welcome to Skip Uni. Under the hood of every modern operating system, web browser, and machine learning framework, C++ is doing the heavy lifting. When Bjarne Stroustrup designed the language in the early 1980s, he built it to handle software at a massive scale. That level of complexity requires strict, non-negotiable rules. This rigorous architectural structure is exactly what allows C++ to reliably run operating systems with millions of lines of code without failing. Compare this to Python. In Python, a beginner can run a single print command and see results immediately. C++ functions differently. It demands a rigid framework before it will process a single instruction. In C++, you are writing more than just instructions. You are building a direct, highly structured communication line to the compiler and the operating system. Every functional C++ program is split into two distinct domains. The first domain is the mandatory compiler scaffolding. This is the syntax required to give the machine context for what is about to happen. The second domain is the dynamic algorithmic logic. This is where your actual instructions, variables, and formulas live. To understand the relationship between the two, we are going to construct the bare skeletal structure of a main.cpp file from scratch, proving the technical necessity of every line. Mastering this foundational skeleton provides a logical roadmap for the boilerplate code that often intimidates beginners. Consider the protocol of a guest lecturer. Before delivering the main presentation, they must greet the host, check the microphone, and acknowledge the audience. That protocol begins with our first required line, #include IOStream. The hashtag commands the preprocessor to intercept the code and prepare the environment before compilation. IOStream, or input-output stream, is a standard header holding definitions for basic input and output commands. If we want to use specific data structures or advanced mathematical functions later, we must explicitly knock on the door of these libraries and pull them in at the top of the script. These include directives are the setup phase, equipping the program with external tools before execution. The preprocessor also handles macros, such as #define x10. This functions as a raw find and replace tool. The preprocessor scans the document and replaces every instance of the letter X with the number 10 before the main compiler ever sees the logic. This phase is entirely about preparing the textual environment, swapping variables, and importing libraries before the logic is translated into machine code. This leads to the second line of our scaffolding, using namespace std. This line prevents naming conflicts, which occur in large codebases where thousands of functions might share the same name. Shouting a common name like Varun in a single room works fine. Shouting it in a massive university courtyard causes dozens of identical doors to open at once, creating a collision. Since C++ has vast libraries of overlapping functions, the compiler needs to know exactly which library's version of a word we are using. std identifies the C++ standard library namespace. This line tells the compiler that whenever we use a standard command, we are pulling from the C++ standard library. This removes the requirement to manually type std::: on every line. Declaring a namespace is a traffic control measure to prevent data collisions in complex programs. The core execution entry point of the scaffolding is int main. Main is the non-negotiable coordinate where the operating system begins reading the actual logic. This is where the guest lecturer finally starts speaking. The curly braces serve as the structural boundary for your code, containing the core logic within a defined scope. Inside that scope, we place our logic command, cout hello. Every logic statement must end with a semicolon. The semicolon is a strict line terminator. Without it, the compiler treats subsequent lines as one continuous broken sentence, which triggers a syntax error. In this hierarchy, main is the stage, the curly braces are the physical walls, and the programming logic is the action happening inside. We finish the scaffolding with the final required piece, return 0. To understand this, look back at the word int preceding the main function. It stands for integer. The program is required to report its final status back to the operating system using a whole number. Returning a 0 is the universal signal for a successful execution with 0 errors. If a mathematical error occurs during the logic phase, the program crashes, and the operating system intercepts an error code instead of that final 0. Return 0 is the formal thank you of the guest lecturer, cleanly handing control back to the operating system. Here is our fully constructed main.cpp code block. The rigid outer architecture is your static scaffolding. The interior space is the dynamic logic. This architectural shell remains virtually identical whether you are printing a single greeting or initializing a massive artificial intelligence matrix. Understanding the mechanical reason for this structure replaces blind memorization with a clear mental model of how the code interacts with the compiler. Every line now serves a specific technical purpose. In the next sequence, we will step inside that dynamic interior box and replace simple text with variables, arrays, and loops. Subscribe to Skip Uni to begin the next phase.